All right, so in these notes, we're just going to discuss, one, how to write the notation for a rotation, and then two, just how to rotate, some rules for rotating points on the coordinate plane. And so one thing to know is that when you're rotating a shape around a point, every point follows its own circle or its own arc. So C moves along this arc, while B moves along this arc, A moves along that arc. So you have all these concentric circles all centered at O. Okay, so this is your pre-image. Every point rotates along its own track, and in this case, it's moving theta degrees. You know, this is a symbol that means an unknown angle. All right, so we have the notation for writing this kind of transformation, and it's written like this. The name of the rotation is a capital R for rotation, and then you have a subscript, and you write a subscript C, comma, subscript theta of P is P prime. Okay, so there's all these parts. This is the name. C is the center that you're rotating around, so this is a different example. But C is the center. Theta is the degree that you're rotating. P is the original point, or your pre-image, and then P prime is your image. So it's like you're inputting this point into this rotation, and out comes the new point. So R just means rotation. Capital R means rotation. Whatever this subscript is that comes second, that is the point for the center of rotation. This next little subscript is the angle of rotation. P is your pre-image, the point before rotation. And P prime is your image. Okay, so there's two examples here. One where you're given a diagram, write the rule, and then one where you're given the words, write the rule. So this is a rotation centered around O. So it's a little subscript O, comma, rotating how many degrees, and I probably should have put a number here, but I just put the variable for an angle. We're rotating theta. That's how far we're rotating. Now, what is going into this rotation? Well, this entire triangle, all 3 points. So, parentheses, triangle ABC. That's your input, or your pre-image, and then your output is triangle A prime, B prime, C prime. Okay, so triangle ABC goes into this rotation, and out comes a new triangle. And we call this a function rule. So this one says write a function rule for each rotation. This is just in words. So C is the center. We're rotating P counterclockwise 30 degrees. So one thing to make sure you know is that this direction is positive, while, let's say, this direction is negative. Maybe I should put an arrow on this. Okay. So we have positive and negative directions. This yellow one is counterclockwise, the pink one is clockwise. So when it tells you to go counterclockwise 30 degrees, it's saying make a positive 30-degree rotation, centered at C. So we're going to have a rotation centered at C, opening up 30 degrees, P goes in, P prime comes out. All right, so write a function rule for this rotation. All right, so now you should at least be familiar with how a function rule looks. Now we're just going to talk about how to rotate points are in the coordinate plane that are being rotated around the origin. Now there's a rule for this. When the center is the origin, there's some specific rules we can follow. So the idea is every time a point rotates 90 degrees, and remember we have our 4 quadrants. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Each one of these represents 90 degrees of the full 360 degrees, each quadrant. So every time you rotate 90 degrees, you move a quadrant. So if you have this point AB in quadrant 1, and you rotate 90 degrees in either direction, you're going to move to the quadrant that comes next. Well, the rule is every time you rotate 90 degrees, your coordinates switch places. So if it was AB and you rotate 90 degrees, now it's BA. But then you have to consider what quadrant you're in. If you're in quadrant 2, every point in quadrant 2 is left and up, so negative, positive. Okay, so 190-degree rotation, you switch, and then just pay attention to which quadrant you're in. If you start in quadrant 1 and you rotate negative 90 degrees, you switch, and you're in quadrant 4, so it's positive, negative. So whether you're looking at a graph or just a point, you should be able to write the image of this coordinate under that rotation. So we're rotating around the origin 90 degrees, this coordinate 3, 5. So you're in the first quadrant, you rotate 90 degrees, you're going to end in the second quadrant. So we kind of have two things. One, we know these points are going to switch because we rotate 90 degrees. So it's going to be 5, 3. Two, we're in the second quadrant, and every point in the second quadrant is negative, positive. So it's negative 5, positive 3. So I'll do 1 and 2, you're going to do 3 and 4. Now we're going to rotate 180 degrees, starting in the third quadrant. So negative 2, negative 7 means we're here in the third quadrant, and we're going to rotate 180. So that's 290s. So notice when you do 290s, you switch, and then you switch back. So every time you do 180, you're just going to switch your signs. We start negative, negative, now we're going to end positive, positive. 2, 7. Okay, so take a few moments, rotate 5, negative 1, which is in the fourth quadrant, 270 degrees, and rotate 1, 4, which is in the first quadrant, negative 90 degrees. And maybe it'd be easier just to come back after we go through the video, so we'll go on to this next question. The only difference here is I actually give you a picture of that point. So K is the point negative 2, negative 3. So it's in the third quadrant, and we're going 90 degrees clockwise. Okay, so that means we're traveling. Clockwise is negative, so we're going this direction. That's the direction we're moving. That's clockwise. So we're going to end in the second quadrant. One rotation in 90 degrees means your points switch places. And if you're in the second quadrant, then it's left and up. So negative, positive. Left 3, up 2. So left 3, up 2. There's K prime. Okay, so write the coordinates of V in V prime after it's been rotated 180 degrees counterclockwise. All right, in this last example, the only difference here is that you're doing 3 points and rotating an entire shape instead of just one. So we're rotating points A, B, and C 90 degrees around the origin. So every point is going to move one quadrant, and the coordinates are going to switch because every 90-degree rotation switches the coordinates. So we know we start negative 2, 5. We have to end 5, 2. In which quadrant are we in now? We started left and up. So we were in the second quadrant, and we went 90 degrees. So now we're in the third quadrant, negative, negative. Okay, 5, 7. Well, that starts in the first quadrant. You're going to rotate 90 degrees. So you're going to end in the second quadrant. So we know the coordinates switch, 7, 5. And everything in the second quadrant is negative, positive. Okay, and the same thing is true for C. This is in the first quadrant. The coordinates are going to switch. Now we're going to end up in the second quadrant, negative 4, positive 3. Okay, so we'll just plot these points real quick. Left 5, down 2. And label them, A prime. Left 7, up 5. left 4, up 3. Now when you look at that, it's a little hard to tell that that's a 90-degree rotation, and you don't have to draw this, but one way to kind of verify it is if you draw a line from your center to one of the points, so let's say from center to C, and then draw another line from center to C prime, well then you can actually see the angle that you rotated, and that's, I think, kind of clear that that's a 90-degree angle, or at least very close to it, so you can see the 90-degree rotation there. All right, so obviously your last you-do question is to rotate this triangle, DEF, negative 90 degrees, write the coordinates, and then plot the points. All right, that's it. Hopefully you understand. If not, send me a message and I'll try to help you out.